Okay. This is our 17th virtual meeting. Excuse me, 18th virtual meeting. So good morning, everyone. The weather was getting warmer, and now it seems to be getting a little chillier again, but that's to be expected here in the Northeast. Our last meeting was held on April 13th. Kevin Rockland and Mike Staley with Don Brown Bus Sales presented on wheelchair lift operation and maintenance. For those of you who just joined, we are recording the meeting like we normally do, and it will be posted to our YouTube channel later on. So some of the things that they talked about was the safeties that are on the wheelchair lifts will shut the lift off, which, we're all pretty familiar with. The Braun lift mandates a new oil made by 3M. The Rycon still uses the aircraft oil that we've all been using. They recommend lubricating the lift with a light lubricant like a BP Blaster, something of that nature. Also, they use door ease on the nylon saddle bushings, and that seems to work out really well for them, keeping it nice and lubricated. It's important that we don't over tighten the manual plug. They tell us that if you damage that, you will have to replace the entire pump because they don't have just the part available. I'm not going to go over what all the switches do, but that is posted on our video that we made and put it on YouTube, and we've referred to that just for which one does what. And it was pretty straightforward: 1, 2, 3, and 4. You want to adjust the lifts with the engine running so that you don't run with low power. The Rycon uses the seat belt where the Braun does not. And if anybody has any issues working on their lifts, on the Don Brown website is the manuals for the lifts, which I thought was really a good idea. So it's a good resource to have. Did everybody receive the survey that I sent out? If you guys aren't receiving the surveys, please let me know. This is how I know what you guys want, whether it's, I sent 2 of them out. One is for training topics for the upcoming school year. The steering committee and myself have been working on getting the dues letter together and putting the training schedule together for this upcoming school year. So I sent out a Survey Monkey. It's a link, and you can click on the link and just fill in what you want training on. The other one that I sent out is for DOT questions. Our next meeting is going to be with our DOT roundtable, and we need questions to ask DOT. Also, with the DOT questions, I put that out to NIAP as well. So we're all working with NIAP we're all on the same page here. So they provided us with a bunch of questions last year that they had, and that's more the transportation supervisors and people that are in charge of the garages as well. So it's important that we kind of include them. I know they had questions for DOT, and as they do again this year. So they also received the link. So today's presentation will be on multiplex systems. Our presenter will be Roger Harrod with Mathewes Bus. So with that being said, I am going to turn the meeting over to Roger.
Well, let me see if I can get this presentation started.
Okay. And everybody should have got the link for the manual for today's meeting. I sent that out. Roger sent it to me last night. I sent it to everybody. All right, go ahead, Roger.
Okay, see if I can't get everything going here. Do you see my screen?
Yes, we do.
Great, thank you. All right, we're going to discuss multiplex again. Multiplex is not a new system, but there still seems to be a lot of concerns and issues with it. I've tried to address this for two different groups. Obviously, the Thomas C2 product is a fully multiplex package where everyone else's vehicle is somewhat multiplexed. And there's some areas why and why not. The original configuration of most school buses were the old PC boards. And this is the way it was, as the slide says, and sometimes it still is. And the case of Thomas is we have both. The Thomas C2 product is a full multiplex package, has been for years, though we still have chassis which are not. For example, our Class Ds, the HDX and the EFX, still have the old analog wiring in them, and there's a good reason for it, and we'll discuss that as well. But all this came about in the mid-'80s, and that's when EPA regulations on the emissions on the engines became so tight that we were no longer able to sell units with the mechanical injection systems, and everyone had to convert over to the electronics, which posed a big problem for the industry because they had lost the mechanical links between these components to allow them to operate correctly. And there had to be an electronic way of doing it. And the Society of Automotive Engineers did come up with a solution for us, which linked in the transmissions, the ABS, the dash, and the engines all together with a diagnostic plug so that we could actually communicate to them. What was added along that process, they also added what were called termination resistors. These were at the ends of the what they call the backbone. And to make them very simple, they clean the system up. They keep garbage from floating around the systems. And over the years, additional stuff has been added to the backbone communications, ABS traction controls and other things that have come out on the market. The big change for Thomas Bus was in 2004. We had a major concern in 2004 because they retired the chassis we were using. We were using the old FS65, which was basically an analog chassis. It was an old, reliable package, did a nice job for us. And Freightliner said that we can no longer use the chassis because it is so old, we do not have the ability to update it anymore. And they gave us instead the M2 chassis, which was one of their commercial truck products, and said we're going to build our new C2 on that chassis. And the big difference between this and previous chassis being used is this was a new design chassis, and it had incorporated the full use of multiplex across the vehicle, which meant that all the body modules and chassis modules that used to be part of the old analog wiring were now incorporated into the backbone system itself. What does that really mean? Well, it means that the Weldon flashers, signal stat, light monitors, child monitors, all the other stuff that school buses have to meet the requirements of a school bus were now programmed into one of the modules. The bulkhead module on the chassis in the Thomas product or in the Freightliner product is the brain, and it is actually a small computer, and it can be programmed to replace all of these components and allow them to be eliminated from the chassis itself. In fact, our chassis today is quite extensive. We have a lot of components in it, some of which are outside the cabin, some are inside the cabin itself. Now, the reason for this change was with the old way that modules were added to a vehicle, what we ended up having to do is interwire all of these different modules to make them work with each other. Take, for example, the Weldon flasher. It's tied into the door, it's tied into the sweep arm, it's the stop arms, it's tied into the warning lights, both the yellow and red, and it operates in conjunction with them only by communicating with each one of those individually. With a multiplex type of chassis, this is much simpler because basically the interwiring is handled through 2 wires. Now, obviously, this doesn't replace all of the wires all of these sensors have on them, but what it did do for Freightliner and Thomas Bus is when the chassis went from the old FS65 to the C2 chassis, we eliminated 65% of the wires in the bus. This is an amazing reduction in the amount of wires in the system. Today's chassis are being built more and more to this every day. However, not all chassis have been converted. For example, even in the Thomas product line, our HDX and EFX are not full multiplex vehicles. And there's a good sound reason for that. And it's one of those old adages, if it ain't broke, don't fix it. Or why spend the money to? And basically the HDX and EFX, which is still partially analog, still works. For us to redesign that chassis and turn it into a full multiplex package would be a very costly venture. And that really does put the handwriting on the wall. As long as you're using an old chassis, you're probably not going to see a full multiplex vehicle. But when the chassis are updated, you're going to see a change. Another thing that you can look at for this, and an advantage to the full multiplex vehicle, is the need for fuse and relay modules. Look at the old PC boards. They were all fuses and relays, and there were fuses all over the bus. And in fact, in the C2, which is a full multiplex, we have only 3 modules in the chassis required to perform all the functions of a school bus. In the body, we have an additional 1 module for a total of 4 modules that handle all of the complexity of what a school bus needs to operate with. Now, that's not saying that there is not some special option or feature that requires an additional relay or fuse on the system, but this is all we really have to make the system operational. Now, all buses, all lines have that basic multiplex system. Our HDX utilizes only this basic portion of it. It has, to accomplish the same needs as the C2, it has, where the PC boards used to be, there are 5 fuse relay centers. Now, these are the same centers that you see over here on the left on the full multiplex C2. We have 5 of them there, plus a couple heavy relays and fuses. Under the chassis, we have an additional module assembly with a whole bunch of transmission components in it. In the dash, I've got more modules, plus the Weldon flasher, the signal stat module, and all the other additional OEM supplied modules there. And in the engine compartment, we have even more. In fact, just the basic modules, again, to perform the normal functions of a school bus operation, we've got 12 modules in the HDX. This is still a lot more wiring and a lot more involved, but it's the reason why we're seeing the move to a full multiplex system is it greatly reduces the wiring in a chassis and the necessary additional components to go along with it. Now, multiplex is sending a lot of messages through the same path simultaneously. There are varying voltage values generated by different computers in a binary language, and it allows us to integrate the entire body into one component. The part of this that's most confusing to most people is the first part. How do you send a lot of electronics through the same path at the same time? And there's really a simple way of looking at that, which is very obvious today, is what they call triple play. And this is an urban internet service provider system where they bring one cable into your home, provide phone, internet, and TV all on the same system. Customer could be sitting on the phone using the computer, watching TV at the same time, yet there's only one wire coming into the house. This is easy for today's electronics to maintain and operate. Now, looking again at what the vehicles have in them, we've got a whole bunch of sensors we've had for years and years and years. This one in the center, the temperature sensor at the top center, has been in vehicles forever. But it used to be connected to a light bulb in the dash, and that was the only connection it had. It was a very analog system. On today's engines, all these sensors are wired into an individual multiplex system just for the engine itself. And this system does what? It communicates information back and forth. The dash lights and any fault codes are generated by the processor on the engine itself today. But people say, well, we don't have multiplex. Yes, you do. There's lots of multiplex out there being used in our vehicles all the time. In our system, we've also been able to make some other changes to it because of the use of multiplex. For example, the switching to our controls is all multiplex, or the majority of it is multiplex, and it's done through unique switches which take advantage of multiplex, and that they're called smart switches. They act more like a sensor than a switch, and each has what's called a unique ID. And these IDs can be seen right here. We have in each switch a set of resistors that identify what the switch is. It's telling the system, I'm, for example, a heater fan. Then below it are 3 additional resistors. A heater fan is a multiple position switch. If we're in the first position, 1 resistor will show on that output. And as we change the position of the switch, the resistance changes. Not opening and closing contact so much as resistance is changed, as a sensor would change. We have some additional components on here. These are LEDs. That's a symbol for an LED. One of just the backlight for the dash when the headlights are turned on. The other one is a switch that says a switch is being utilized. But the point of this is we have 2 modules in our chassis that are connected to switches. And that's the switch hub module, which is in the body, and the bulkhead module in the chassis. The switch hub module has 24 positions where one of these switches can be installed. The bulkhead module has an additional 5. And every second, 8 times every second, every switch is looked at by the main processor, in this case the bulkhead module, asked who they are, and then looking at what the position the switch is in based on the resistance. Now, what this allows the system to use is we don't have a dedicated circuit for any of these switches. We can put any switch in any position in either of these processors locations, and it'll still work. Now, what that also means is you have the option with multiplex, with this type of features, to move any switch to any position anywhere in either of these 2 areas, and it will still function. They also don't carry the load of the circuit. They're basically just a signal to the system saying, I want you to work. Another beautiful example of that is the multifunction switch on the steering wheel. This is on the left side of the steering wheel. It carries 6 wires out of it, yet it has 15 functions. 2 of those, by the way, are a switched function. There's actually a switch on wires 2 and 3. That is the hazard switch. So if we eliminate it, we've only got 4 wires left, but yet we can still maintain 14 functions on this assembly. And this is with minimal wiring. How do we do this again? By moving the switches, the individual switches, we just change the resistance on the circuit, and the computer can analyze this easily, and it establishes by that what the driver is requesting. Again, this is a wonderful system. Now, elements of multiplexing. You basically something has to happen. A driver has to move a switch, a temperature, pressure is reached, a difference is noted. This is an input to multiplex. We then have to share that information around the vehicle to let them know this has happened. And then the devices that are responsible for responding would take the action and make a change. For example, the simple factor of turning on the headlights. The switch is closed, and that signals the processor the driver has requested the headlights to come on. That module would then transmit that information to every other module on the bus along that twisted pair of wires, that yellow and green circuit called the backbone. Every processor in the bus is identified that we want the headlights turned on. But that signal also has an address on it, which identifies which processor is supposed to do something about it. In this case, the chassis module is the module that was identified, and it would then send 12 volt to both headlights. Now, this is the simplest as you can get with multiplex. We actually go a step further than this. We don't do it this way. We do it this way. The bulkhead module turns on the left headlight, and the chassis module turns on the right headlight. And people ask, why do you do this? And the simple answer is because we can do this. We want to do this for one very important reason. The headlight is one of the highest uses of energy on the bus. That is 7 amps continuous. It would be much better if we could share the load between two processors than try to take it all from one. We're only sending 7 amps from each processor to a headlight versus having one processor do 14 amps to 2. It's load sharing, it balances the load, it reduces wiring. Now, parameters are the instructions we give the processor, and the processor we're talking about here is that one right there to the left. That processor is basically a computer, and it has been programmed to eliminate all of these components, for example, in a school bus. It also means that we don't need any of these components themselves. They're not necessary. The processor can handle all of their applications. And it also means I can very easily change the way they work by just changing the parameters on the system itself. Now, how does multiplex actually do this? This is the part that we get into diagnostics, and we get into some of the repair scenarios. You have to understand how it's actually accomplished. We control the output of the systems through what they call FETs, which are field effect transistors. It's just a real technical name for a little switch. And these switches control the circuits. And they can either turn a circuit on and off by disconnecting the power side or the ground side, depending on what type of circuit they're connected to. They're also current and load specific, meaning if there's too much load on a particular circuit, unlike a fuse that would burn out, they're like a circuit breaker. They'll just open. How are they reset? You basically cycle the ignition switch and you reconnect them. A typical FET on our system is a 7 amp FET. So if they saw 8 or 9 amps versus, rather than burning out, they would just open. How would reconnect? We just cycle the ignition switch. Now, this became a problem for us back years ago. When we first got into this, we had a serious concern with windshield wipers. Some smart engineer decided that since windshield wipers only use 3.8 amps, we don't need a windshield wiper relay. We'll just use the FETs, and they can handle the load very nicely. Well, the problem is that particular engineer never lived in the Northeast. And we all know that if we freeze the wiper blades to the windshield, you'll blow a 20 amp fuse, which is exactly what it was doing. Now, the problem would be the driver would go out, not clean the windshield wipers, turn them on, it would blow the FET. They would clear the windshield wipers, and of course, they wouldn't work. They would have worked if they did one simple thing. If they had cycled the ignition switch, the wipers would have worked fine. But we all know that's asking in a lot of drivers. So what we ended up doing today, and from that point on, in fact, we're now using relays again to control these major loads. And this is pretty simple. Basically, we've got the processor over on the left there. Its circuit goes over to the relay and just energizes the relay. So there's very little amperage load on the FET itself. Now the relay would close. It's connected to the motor and to a fuse and the battery. Now, this is what we do on every motor in the system today, is all the motors are controlled by relays, but the relays are controlled by FETs. And this allows the system to operate perfectly well. Now, there's one additional difference on the windshield wipers. On the windshield wipers today, on the C2 product, we do not use fuses. We use self-resetting circuit breakers. In fact, they're the only self-resetting circuit breakers on the entire vehicle. And what they allow, of course, is when the system does fail, the drivers don't clean the windshields. By the time they go out and clean the wipers and come back in, that resetting circuit breaker has reset, and now the wipers will work fine. The big difference in multiplex is diagnostics. This is where we get a lot of confusion. FET controls the power to an output either by switching the positive or ground side. And it really comes down to, are you looking for a problem with power or ground? You need to check the wiring schematics. If you check the wiring schematics, for example, on our dome lights, you will find there is no ground in the system. The schematic shows there are no grounds whatsoever. So we are switching the ground side. So when you're looking at problems in that system, you're going to be looking for, where do I have problems? Is there no power going to the system? We can also go through the connectors and find out if the modules are actually grounding the circuit correctly. Another thing is the load. You have to be careful, they are load specific. They act like a circuit breaker. Too much load will result in opening that circuit up. Here's a good example of here. Again, using the dome lights. On an analog system, typically, again, ground is used. If there is an intermittent short to ground on a dome light circuit, what will happen is it will blow the fuse. The driver would come in and say, my dome lights don't work. The mechanic would come out and they would inspect the unit and find the fuse is blown. They put a new fuse in it and they would work again. Well, they'll work again until what? Until that bit of wire that has been grounding out against the frame rail here someplace, touches again, and it'll blow the fuse again. You didn't fix the situation, you put a Band-Aid on it. The load we need to correct where the intermittent short is occurring. Now, the problem with a multiplex system is the driver legitimately had no dome lights. The fuse had blown. So he had written it down on his work order. It was turned into you. You went out and checked it. And again, with the analog system, you just put a new fuse in it. With a multiplex system, if the ground default was opened, meaning it no longer shorted to the frame rail, as soon as they cycled the ignition switch, it fixed itself. Excuse me. You've got to trust your driver's reports. If the driver says the light wasn't working and you go out and try it yourself and it is working, it could very well be that there was a fault, but when you recycled the ignition, you reset the FETs, and now we have a Band-Aid put on it. Now, from what I'm going to cover from this point on applies to all multiplex systems. And that's the testing of the data link. Now, the big question is, why would you want to test it in the first place? Because if the data link fails, the bus won't start or may not start. This applies to all vehicles. Now, where you can test the data link is at the plug in the vehicle. This is the common, the J1939 data connector that's found in most of our vehicles. In fact, it's found in all of them except the small Class A's. In it, you have a couple pins that have never been used. The E, J, and H pins have never been utilized. The old 1587 system, which really hasn't been used in the last 10 years, is on pins F and G. The current wires we're using are the 1939 circuits. They're on pins C and D. A and B are ground and battery 12 volt. And it has to be battery unswitched 12 volt. Now, the most common tests we do here, there's only 4. The first one is to go between pins A and B, and there has to be at least 12.4 volts DC. Period. I mean, that's a very, very simple test. You have to have enough voltage for the system to work. Now, since this is battery, it doesn't matter if the battery is if the ignition is on or off, it makes no difference. Now, the next test you want to make on that system is test number 2 here, and that's across pins C and D. And this is with the ignition off and or battery disconnect. And what you want across pins C and D with a good ohm meter is 55 to 65 ohms. If you don't see this, then what we have to find is where are those termination resistors we spoke of much earlier today. The biggest challenge here is finding them. They have to have individually 120 ohms plus or minus 10 across them for the system to work correctly. Now, the third test, or fourth test rather, is one that we see with a couple of the engine manufacturers. They want you to check the voltage from ground, pin A, to D, or ground to pin C, with the ignition on. And on the yellow wire, you'll see 2 to 3.5 volts DC. On the green wire, you'll see 1 to 2.5 volts DC. This is with the ignition on. Now, that's a good test. Here we are with test number 2. This is the one going across C and D to check for resistance on the circuit. And this is with the ignition off. Now, probe between those two. If you have an over limit, you have an open in the circuit, and that's a bad situation. And what I mean by bad is somehow or other, this backbone has been disconnected. There's a break in the system here, an open circuit. That's bad in the sense that the bus won't start. Why are you checking this? Because the bus didn't want to start. Now, if you see 0 ohms across here, you have the same situation. You've corrupted the data in the backbone. The engine, transmission, the start system will not operate. The bus won't start. If you see 60 ohms, that's what our chart looked for. That's a good one. It says you have 2 good termination resistors. The system's operational. Now, if you see other things like 120, well, 120 says you've only got 1 resistor. Again, somehow there's a break in the circuit. Not a short, but there's a break in the circuit. This is not good. Now, what do I mean by not good? Not good means the engine probably will start, but you're going to have some situations that are kind of crazy with it. It's not going to work correctly. Likewise, if you see 40 ohms, that means somehow or other there are 3 resistors in the system instead of 2. That is another not good situation. The engine may start, but it may not operate correctly. And again, here we're going to have to get some help from somebody because we're going to need some help. Where did that 3rd resistor come from? And lastly, if you see any other resistance value in here, for example, you get 75 or 22, you've got a bad resistor. There's something wrong with the system. Again, the engine may start, the vehicle may operate, but not well. This is also a very difficult test in a school bus to do. Why did I say it that way? Because that connector we're trying to plug into is not in the most convenient location in most school buses. It's usually on the driver's side, below the dash. Why? Because in a truck, it's very simple to open the driver's door set your laptop or ohm meter on the floor and reach up and connect to this connector. Unfortunately, in a school bus, we don't have a driver's door. There's another way of doing this, a lot easier. This happens to be our bulkhead module. This is on the inner fender on the left side, mounted to the firewall, and right on it is connector 2. And if you look at pins B and J, I have arrows here to them, you have a green and a yellow wire. What we have found here is the harness that goes to the backbone, and the pins here at the top, that yellow and green pin, are exactly the same circuit as that. And in fact, we can plug into here a lot easier and test our resistance, test for voltage, test for all those other things, much easier than we can under the dash. The only thing we cannot do from another circuit is the pins A and B. The first test was to go to A and B and see if we had 12.4 volts minimum. We can't do that from any other location than the reader plug. But this makes it a lot easier. In fact, any module on the bus, if you find the connector that has the yellow and green wires in them, twisted pair, as the example shown here, you can use that to test the circuit. And it's a very simple way of testing the communication around the bus. Now, this particular test is a little bit different, and I'm going to try to explain it to you very carefully. A digital volt, a high impedance digital volt ohm meter, which most of us are using today, is an extremely sensitive tool. If you were to place it on voltmeters and set the range to auto ranging, it will do something quite unique. If you just hold the probes up in the air, touching nothing, you'll see on the meter what's called a ghost voltage, a voltage just fluctuating in the gauge. It actually has the ability to read the electrical energy in the air. Again, if you touch the two probes together, it will go to 0. Meaning there is continuity between the two probes now. That concept's very interesting because this allows us to do some really neat things with the voltmeter. For example, if you probe pin C or pin C to a good ground with the ignition off, if the voltage is a ghost voltage on the screen, this is showing there is no continuity between ground and the backbone. This is a good situation. It means there's no short to ground. If, however, you read 0 voltage, this is an absolute example of a short to ground. And again, the word bad. That word bad is there for a reason. That means that the bus won't start. You have shorted out the backbone. The controls are dead. One last thing you can do with this. You put a voltmeter into the circuit. If the voltage reads more than 4 volts. Now understand what the previous slides we looked at said the A to D or A to C, we should see a voltage, but that voltage never goes above 3.5 volts. If we've got more than 4 volts, you have a short to power. And another reason why the engine won't start. You can't have a short to power. And you want to make certain that your technician checks this with the ignition on and with the ignition off, because I could have a short to battery power. You'll never see that one. I could have a short to ignition power. You'll never see that unless you turn the ignition switch on. So this is really an important step. A couple last things to talk about. There is the connector underneath the dash. The current one since 2016 has been a green connector, meaning that the vehicles are now operating at 500 baud rate versus the previous 300 or 250 baud rate. The reason I want to put this slide up here is to discuss the former NextQ USB Link. That was an excellent tool, but it was designed for 250K. There is an adapter cable which allows you to replace the original cable on this and plug it into the green connector. Do not do that because it will not work correctly for you. If you are trying to maintain your operations and your tooling correctly, get the new current USB Link 2 unit. It is designed for the newer packages today, and it'll work a lot better. Lastly today, if you're looking for an inexpensive diagnostic tool to improve your vehicle service experience, I want to introduce you to the NextQ USB Link or Blue Link Mini. It provides basic vehicle information and trip information, fault codes, and the ability to email all this to your service provider. It is a slick little package. There's an example left on data. Obviously, you can't read the stuff very well, but the best I can do on a PowerPoint presentation. On the right are fault codes. Now, the neat part of this is this interfaces with your smartphone or your tablet, whether it's ISO or Android, doesn't matter. You go on the internet and you download the proper apps. By the way, there's 2 of them out there. The DTNAE link, I really don't like. The first link, which is one of NextQ's options, really works very nicely. They're free. They're free. Now, the real value of this is right here. You have the ability to email all of this to your service provider. I'm not talking about sending it to Mathewes Bus. I'm telling you, you can send this to Leonard. You can send this to New York Coach. You can send it directly to the people you need to know. You need to have the information. For example, this is the NextQ version. After you have plugged this unit in and gone to your smartphone or your tablet and downloaded the information, basically you just rescanned it, you'll see this screen with a NextQ package. You could click on faults or life trip, or you could vehicle specs parameter. You could click on any of those and actually read the information on your smartphone. But the last one here, the report option, is the neat one. If you click on report, it then opens the second screen up here. What you want to do here is click on mail. Now, obviously, your tablet or your smartphone has to have access to the internet. After you clicked on that, you'll get this screen. In this screen, what you want to do is type in the email address of who you want to receive this information. In this case, this is Bob Baker. He's my service advisor in Liverpool, New York. You then click the little button over here on the right, and this thing has just sent the bus VIN number, the date code, the fault area, the fault codes. It gives them the opportunity to check for previous faults and the ability to bring the correct parts the first time to repair your unit. This is probably one of the most cost-saving things we have ever come into. This is, in fact, at the point in our company today that our sales department, on the delivery of new units, we deliver one NextQ Blue Link Mini with it, with the information on how to use this. Where do you get this thing? Well, there's a part number. You can get it from us, or better yet, go to Amazon.com and order direct. This has proved to be an extremely helpful tool and saving us a lot and the customers a lot of time. With that, my presentation is complete, but I will be very happy to answer any questions you have. Is there anything that I'm missing?
Hey, Roger, when you test that data link, do you generally find a lot of issues with that?
No. The data link is probably one of the most resilient communication harnesses in the entire bus. You're basically testing it because you have a problem that you suspect might be connected to it. And that's why that simple ohm test, and short for ground, It is so simple to do, and it basically says there's nothing wrong with it. We go on to other areas. It really is overplayed at times. People say, well, it's got to be in that. It probably isn't in that. The biggest problem you have with any wiring circuit today is the connectors anyways. If you get corrosion in the connectors, you have problems. And it doesn't matter if it's a data link or whatever it is, a light switch. But checking the data link is something that people don't do quick enough at times, because you really need to find out, is there a problem with communications? And that'll tell you very quickly. If you got 60 ohms and you don't have a short, you don't have an open, there's nothing wrong with that. Let's go on to other areas of the vehicle.
All right, what about when you said that you could go to the bulkhead module and test the green and the yellow wires for the backbone? Is that a common failure point? Like, do you see a lot of failures there?
No, it basically is a lot easier to check it in one of the other modules. And the C2 in particular, you're laying on your back with an ohm meter on your chest trying to do that test the way the factory wants you to do it. The other system that I explained using one of the other modules, I've gone through it with the factory and they said it's a great idea. You know, it's a lot simpler, it's a lot cleaner. And for example, one of the problems you have laying on the floor, if your elbow goes back and hits the brake pedal while you're doing it, you just turned on the whole system. Because anybody knows, you touch the brake pedal, the dash lights up. Well, now instead of getting a nice ohm reading that you want on a dead system, you've got one from an active system, and it's going to really tear you up. Don't make this hard. This system's simple.
Okay, does anybody else have any questions for Roger? If you think of any, you can always email them to me or email them directly to Roger. If you post it to the head mechanics, I'll make sure that he gets it and he can answer the question at a later date. If nobody has any questions for Roger, we're going to move on. I want to thank you, Roger, for your time today and putting that together. That was very informative. Moving on to some other items here. We are still looking for a treasurer. So if somebody would like to step up, we'd really appreciate some help here. The rest of us, we're all trying to make things happen. Our ASC certification is moving forward. It's going well. James Lorette at North Colony Central School District is going through some training now. And then as soon as he's ready to take the test, we'll purchase the test and he can move on from there and become Master School Bus certified once he's ready to take the test. So that's where we're at with that. We're going to be doing more people once we get towards the end of the year here. Our Christmas party will be announcing 2 more people for this year. So think of if you have any people that are working for you at a school district that you feel would be a good candidate to become Master School Bus, become a Master School Bus certified technician. You just write a letter, send it to George Giel or Christine Lennox, and I will get you their emails, and it'll be in our newsletter as well. We don't want you to forget about it. We want to keep pushing this, and like I said, we'll be working towards getting 2 more people. Our next meeting is going to be the DOT Roundtable. It's going to be on June 15th. As of right now, it's going to be virtual. That's where that survey that I sent out comes in. On that survey, there's a question that says, would you prefer a virtual meeting? Because everybody's driving these days. That's where it's coming from. The COVID is not really keeping us apart anymore. It's leaving our shops. is becoming the issue. So, but if you would prefer it to be a virtual meeting or in person, there's 2 selections on there. Please give me some feedback. Let me know what you guys want to do. Along with that, don't forget about the other survey for the training. We need to know what kind of training that everybody wants for this coming up year. And again, whether those meetings should be virtual or in person. Please take the surveys. I got the NIAP is going to be attending the DOT roundtable. If it's going to be virtual, which right now the feedback that I've got from the surveys is that it is going to be virtual, we probably will invite the other chapters, the other head mechanic chapters to this as well. So that'll open it up. Hopefully we can get a lot of questions, a lot of people attending that meeting. Last year we had, I want to say 50 some cameras on that. And on every camera, there's more than one person usually watching. So with that being said, does anybody have anything else to add to today's meeting? Anything at all? Okay, well then I'm going to close today's meeting. But please take those surveys, and if you're not getting them, please email me. And if you do think of any questions, you're not getting the surveys, email me your DOT questions or your training topics for the next year that you would like to have. And at this point, I'm going to close today's meeting. Thank everyone for coming. Thank you.